Hey WeldTube family, we're back at Miller today. We're at the pipe welding shop and we're doing some more TIG today. We're going to be simulating a chrome joint. We're going to be using carbon pipe, carbon TIG wire, but we're going to be simulating the chrome with the preheat. Travis?
Now the technology we will be using is the Miller ProHeat 35 with a rolling inductor.
Warning: read and follow all labels and the owner's manual.
Now to explain more about the technology right here, we have Al Sherrill with Miller Electric. Al, do you want to explain a little bit about this machine?
Yeah, thanks Travis. This is our ProHeat 35 induction heating system. It provides up to 35 kilowatts of heat. What we're going to utilize today is a tool that we're using for a rotating pipe. We can't just put cables on a rotating pipe because the cables will be twisting around as the pipe is rotating. So we invented a tool called the rolling inductor. And what this is the induction coil sits right inside the inductor, and as the pipe rotates by it, the induction field induces the electricity inside the part and causes it to heat up. So we've got this rolling inductor set up on this 6-inch pipe to heat this joint up to 400 degrees. Now when I'm trying to get 400 degrees into the joint, I want to bring the heat up a little higher than that to help push 400 into it. So I've got the set point on my ProHeat set to 430 degrees. I've got a remote start here, so I can just start this and we can get started with our heating. I've also got a travel detect on here that's going to prevent the unit from continuing to heat if we stop rotation. It's very important if you're working on expensive parts that if you stop and you overheat a spot, you're going to have to cut a section out and repair it. We want to avoid that. So this travel detector here is going to prevent that for us. The other thing that I'm going to look at is this infrared detector down here. This is what's actually going to monitor the temperature of the pipe and give the feedback to the machine so the pipe temperature is reported and it knows when to start turning the power down when it's at temperature. So we're ready to turn this on and start heating the pipe. I'm going to go ahead and turn the output of the ProHeat on with my remote switch, and we're going to go ahead and start rotation. Now as soon as this realizes that we're rotating, it's going to go ahead and start turning the output on. It comes up from a slow start, so because we don't know if you're heating up thin material or thick material, so it brings it up slow to make sure we don't overheat it. So it only takes a couple of revolutions to bring this up to temperature. You can see I'm not to temperature there, but you get within a few inches and bam, you're melting all the way out. So we got a few inches on each side of the joint, just like the code wants us to be.
All right, so what we're doing is a simulated chrome rollout. Using carbon pipe, 70S2 carbon wire, 1/8 filler wire, 1/8 gap with a feather's edge. Heat, we're going to be running hotter in this situation because we're rolling it out.
Now Dakota here, he's using a gap a size smaller or equivalent to the size of the filler metal, and he's just, lay wire technique. So he's walking over the filler metal and letting that weld puddle just sink in. Usually with this technique, if you do not see those sharp V's in your ripple definition, but you see like a C formation, it's not hot enough to sink that weld puddle through the gap.
It's one of those things, after you do it for a while, you kind of get fine-tuned into it. You know what to look for. That V with the center down, exactly like Travis is saying. You see that, you just keep going. Coming up to attack, so we'll stop here. All right, so same kind of thing with RMD. You want to take that grinder, feather that stop out. With this high amperage, sometimes it leaves a pinhole in the end, and if you don't grind it and thin it out, there's a chance that it might not catch, and then that'll show up clear as day on x-rays. So thin it out, feather it back, have a nice ramp to start, let that heat sink in and go.
And also the other thing that's very interesting when you stop the arc, usually when you have a really uniform, nice root pass, when you break the arc, keep the filler metal in the weld puddle momentarily, and when it right before it extinguishes, pull the filler metal out, because you will break the arc with the filler metal mass in. That way your root pass will not sink. Yeah, no, this root pass, gorgeous, gorgeous.
You heard it from the king himself.
Elvis?
Big thing with this process too is you got to keep that filler wire in your puddle, and you just keep pushing that filler wire in. So I'm coming up to my tie-in here. I'm going to slow down a bit. I got it feathered out to a nice ramp. Let that fusion get in there, tie it all together. And then you want to taper out too with this kind of temperature, so you're not just snapping out of the root. Alright, so root passes in, we're closed up. I gave it a little bit of a cleanup. We decided we're going to take it out because everybody likes taking stuff out. So 1/8 rod for the hot pass. We're actually going to do stainless to make it look pretty. I'm going to go about similar heat, just a touch hotter than my root pass. You don't want to blow through, melt through anything, but you really want to fuse, get that pipe to shrink, and you push that root through. So yeah, for this, you want to wash that heat, wet out to each side, wash up the bevel wall. You don't want to focus too long in the center and remelt or potentially blow through your root. Get a heavy spot, get sucked back if you're in position.
And the XMTs are gorgeous machines for TIG welding.
Yeah, we both use them at the shop.
Oh yes, both of us, we both have the Dynasty and also the XMTs. Fantastic machines.
So it's running an 8 for root and hot. I'm going to step up to a number 10 now that I've got a little bit more material deposited in that bevel. Starting to come up, and that 8 was catching on the deposited metal.
So basically, as you just saw the hot pass there, you'd notice that the nice teardrop ripple definition from side to side, he's carrying the energy and kind of pushing the weld puller around, but he's not keeping the energy focused on the root pass, because you do not want the hot pass to soak and saturate and push that root pass in.
There you go. All right, so changed up positions a little bit. You get that nice flat flush, you use gravity a bit, get that buildup of material. We're going to be running the same heat. We'll see how the puddle looks. I might go a touch harder to get this buildup, flush it.
Now if you notice a change in Dakota's welding technique, he's walking the cup with the puddle away from him, so the torch is going away from him. More of like an uphill kind of progression.
Alright guys, we're flushed out, brushed it. No oxides on there. We took the flapper to the edge before. Let it cool down. You check your inner pass, check the preheat for chrome, and then we're going to cap this out. So 532 rod, 200 amps, and we're going to cap it.
Now basically for the finished product, Dakota is just walking the cup and he's going to have a really nice weld definition, like really nice ripples. And it's like really nice teardrops beside, and different welders have very different techniques. It's kind of using a technique where it kind of it's an up and over, kind of a half moon technique. Kind of pause on one side, and then when he comes over to the bevel tip or the edge of the pipe there, he gives a little bit of a flick, so a little bit of flick, and the puddle just kind of washed over a little bit.
All right, so that was the mock-up chrome joint. Heated it, rooted it. Thanks guys, have a good one.